Hello everyone, thank you for joining us. So today we will learn SAP BTP, cloud environments, CAP models and build code with Joule AI. We'll cover the basics and advanced concepts and how to use them in simple steps. So let us begin. First of all, we will discuss what is SAP. So SAP stands for Systems, Applications and Products in Data Processing. It is a global software company that helps businesses manage their day to day operations. In simple words, SAP is a business software that used to manage things like finance, sales, human resources, inventory, and production in one system. For example, companies use SAP to track sales and customers, manage employee payroll, control stock and inventory, handle accounting and billing. So, SAP helps companies to run their business in organized and digital way. So, what is SAP BTP? SAP BTP stands for SAP Business Technology Platform. So, BTP is SAP's cloud platform for building and running business applications. In simple words, SAP BTP is a platform where developers can create, manage data, and connect systems in the cloud. It helps companies to build cloud applications quickly, connect SAP and non-SAP systems, manage and analyze data, use AI and automation in business processes. So let us set up a BTP trial account and look ahead and explore all the concepts in BTP. What are the environments available in BTP? What are the programming models available in BTP? So, before moving ahead, let us set BTP trial account. So, to create free trial account, use this. You have to register one account on sap.com. I will share this path with you. I'll begin this process. Click on try now button. I will use my email to log in. Click on next button. I will click on continue. I will enter my password and continue to log in. Now you can see that I am logged in. I will click on this button. Click here to start your trial. Here select region. Click on create account. So this global account is getting created. Meantime, we'll discuss these concepts like global account, sub account, and regions. So, what is a global account? Global account is a representation of your contractual agreement with SAP. You don't actually build anything on this level. You administer and gain tight governance on this level. Regions are basically the geographical location where application data and services are hosted. Sub accounts hold together your application, services, and subscription and allow you to organize and structure your global account. So the actual work is done on this level. So here you see that this is getting created. Let us wait for a minute. So this account is set. Now click on continue. So basically this is the home screen. and you can see that welcome to the SAP BTP. So these are, and you can see the quick tool access like SAP Business Application Studio. We are going to use SAP Business Application Studio to develop CAP application, Fiori application. For now, we can enter our trial account and set it. So we can develop CAP application. Here you can see this is the, you can say, first screen. Here you can see this is our global account. And in global account, you can see that a sub account is created. Basically, the work is done in sub account, and you can create multiple sub accounts. So suppose you have uh, you basically you want three systems. Suppose you want one sub account for development, another for quality and testing, and then you want to one separate sub account for productions. Here you can see entitlements. In entitlements, you see that the service assignment, this in this section, let us wait. Here you see that all the services available, so we are entitled to use this service. So basically this is a trial account and we don't have to pay for this service, but for a business account we have to pay for this service based on subscription or monthly basis, depend upon the contractual agreement. Here you see the security, you see the role collection. So basically, role collections are the collection of roles. So suppose this is one role collection. We have global account administrator. So this role collection has these roles: audit log auditor, global account admin. So without these roles, these activities will not be performed. So we assigned role to role collections, and these role collections are assigned to the users. So let us see here that this global account administrator role is assigned. We can also assign another roles like see global account viewer. So if we want to restrict some user to viewer only, we can assign this role. So like this, even we can create our own roles. So basically this activity is done by BTP admin. Here you can see boosters. Let us click on this button and let us check what this boosters is. So basically, suppose you want to prepare an account for ABAP trial, or you want to add configure a mobile application backend. So if you want to add this service, so instead of following the complex process, you may miss some process. So boosters will give you a workflow or a wizard type of way to register this service, create instance and service keys. So we can do this, we can follow to add this service in our BTP sub account. So this is a effective tool, and to set up some service we should follow this. So later we will create HANA cloud, so we'll follow this. So for now let it be, and let us enter our sub account. So again I'm navigated back to uh, the home page. Now I will click on go to your trial account. So here let us enter our sub account now. So in this sub account you see, so let us focus on the environments. Basically here we see three environments: cloud foundry environment, kaima environment, and there is abap environment also there. So let us check all these three environments: Cloud Foundry, Kaima. ABAP environment is not added, so later we will add if that will be required. Basically, ABAP environment is required for ABAP. Uh, Basically, if you want to develop application using wrap concepts, so basically it gives traditional ABAP programming environment using core data services and HANA. So let us check these environments. So Cloud Foundry basically it is a open source platform as a service, and it is ideal for developing enterprise grade cloud applications. Kaima is like managed by Kubernetes, and there are containers, and it is event driven. So basically, ABAP environment is modern. ABAP platform as a service designed to build cloud application using ABAP tools. So basically, there are two programming model. One programming model is cloud application programming model, and we use this model for Cloud Foundry environment and Kaima environment. So basically, Node.js, Java, and core data services are used to create CAP applications. And RESTful ABAP programming model RAP is like it is perfect for ABAP developers. So who are transitioning their skills to build application in cloud environment. So it is like evolutionary and standardized programming model is specifically tailored for modern ABAP development. So basically, RAP is for ABAP development, and CAPM is for app, cloud development for Kaima and Cloud Foundry. So these are the differences. You can explore these, and so let us check what is Business Application Studio. So let us close this. So here you see that with this trial account, this API point, basically Cloud Foundry, is created, and now we'll explore Business Application Studio, and we'll try to develop um, CAPM application, our first CAPM application. We can go to these instances and subscriptions. Here you can see that Business Application Studio, one subscription Business Application Studio is by default added in this trial account. It is subscribed. So like this, we have to subscribe these services, and this is a trial. So there is we don't have to pay for trial account, but for production and business account, you have to pay for each and every services. So let us navigate to, and here you can see that in Cloud Foundry, you can see a space, right? So basically, in a space, you store your applications, and you see that there is organization quota and memory space is allocated. Let us develop one CAPM application on Business Application Studio. So this is the home screen of SAP Business Application Studio. Click on Create Dev Space. So basically, uh, we create a dev space to basically a space. You can say it is a repository or folder uh, we create, so we can create our application here. So suppose to create a CAPM application, we require some plugins, we require some uh, packages, some fundamental tools. So so that should be added to your space. So if we are creating a CAPM application, I would suggest this second option. This is the kind of application like full stack application using productivity tool. We should select this. Even with this selection, you can develop Fiori application. And the first one is basically for SAP Fiori. If you want to develop only Fiori application, you can select this type. But if you select this full stack application, you can develop CAPM and Fiori both. And there are others also, but for CAPM, you use this tool. Click on Create Dev Space. So we have to provide a name. Suppose I'm giving CAP. So this is the name I'm giving to this space. You can create multiple spaces here. So basically, you keep your application separately. Click on Create Dev Space. So this space is getting created and you see the message that it is starting. So for your information, you can read these notes like basically it is a trial account, so your data will only available till 30 days and it will be deleted. And you can create only two spaces in uh, trial account, but in production account you can create multiple spaces. So let us wait for a few minutes and it will start, and then we will understand what are the options and features we have in business application studio, and we will create a CAPM application. Here you can see that we have created a dev space with name SCAP and it is in running mode. As you can see in the right side that we have buttons to start and stop this dev space. You can delete it, rename it, etc. So let us click on this SCAP and see how we can develop our application in business application studio. So before starting the development, let it load, and meantime we will explore the capability of business application studio. So business application studio, or simply BAS, it is a next generation cloud based integrated development environment that is tailored for SAP development. So it is built on Eclipse, Thea, and it offers desktop like experience. It is similar to VS Code. So as we have created a dev space, you can quickly spin up, isolate optimized workspaces for different scenarios. Like suppose you want to uh, create SAP Fiori application, so you can create a separate space for that. If you want to create a CAP, you can create a separate for that. And if you want to create a HANA app, you can create a separate dev space. So basically you can build, deploy applications to cloud foundry, and also you can deploy applications to the on-premise SAP systems, etc. So business application studio can connect to the on-premise systems as well using cloud connectors. So now let us explore more about business application studio and create a CAPM application. So here you can see that these three buttons right here. Click on this button, you will see files, and you will see options like open file, open folder, import project. You can import project from your desktop, and here you can see that new project from template, and you can add folder to workspace, etc. These options that are required while the development. You can see the edit, where you can see this how to comment and shortcut keys for block comment, toggle comment, and other options you can find. So there is one important option here. You can see that is command palette. Suppose I'm creating a Fiori application. So I let me enter a Fiori. So here you can see there are multiple options to. You can see this open application generator. It will open the generator, and deployment configuration you want to add, launchpad configuration you want to add. So these are the set of tools and configurations that we can easily access from here. So let us check if anything available related to the CAPM. As you can see, so you these things, notebook page and release note cap, show cap release note. So let's see what is this. So it's loading. So you can see that cap Node.js Java. So basically cap is developed on Node.js and Java for service handling, and you see the CDS language, cap Node.js, everything you can access from here. So all right, also you can see other options such as see this button. This is basically the explorer. So from here you can explore the folders, and you can create folders. You can select the path where your application is stored. So I'll let you know on which folder we are going to create our application. So let us explore other buttons like see this is basically CI/CD. So CI/CD content integration and content delivery basically we use for scheduling jobs and deployment. This is the log. Let's see, this is Joule. This is Joule is like AI of SAP. So Joule agents are there. Joule Copilot is there. So with Joule, later we will develop application using prompts. So we are going to explore it later. And here you see this is Git. So if we are deploying and if we our repository is cloned to Git, so it is basically from here you can control Git. And these are the run configurations. So basically we'll create a run configuration to run and test our application. Also we will debug application with run configurations. So these are too many options and we are going to explore all these options one by one later when we progress our development. So for now I will click on this open folder button. There is a folder project. Here you say follow this path, home, users, and all that. You can, if this path is not available by itself, you can write it down and you see select these folders, right? Projects. So let me click on this. You see that this is added and click on open button. So this project folder will load now. In this folder, we will create our CAP application. So let it let this folder open, and meantime I will explain a few more concepts of CAP. So I'm creating a new slide, and here you see, okay, so I will explain you one concept, that is MTA, multi targeted applications. So let us adjust the font so it will fit on the screen. So anyway, so what are multiple multi-targeted applications? So suppose there is one application. Let's see, there is one app, and that application has multi-targets, multiple modules. So basically, like we have a app. Like let us assume one scenario that if you have one app, and that app is depend upon API for data, right? To get send data basically, and this API is fetching data from some database, right? So this application will send request to the API, and API will receive data from the database and uh, send data to this database. So this so basically most of applications are following this, right? So suppose if we have one application, we have one app. So if you bring together, if we bring this in MTA, if you bring all these things, app, API, and DB. So here we create entities to define data structure. So so if we bring these things, so these will be the modules. Like one module is app, one module API, inward. So these are three modules, right? So all these things comes together at one platform, and you can have multiple applications. Basically, in a nutshell, we can say multiple applications can be developed in one project, or you can say in one app also, if we consider that project as an app as a whole. So this is MTA. So there is a file. So cap app is basically, cap is a multi-targeted application. So a cap has, basically cap has these three parts. So this is the structure of cap app. Multiple application can be used. So that is called MTA app, multi-targeted. So there is a one file that is called mta.yaml. So in this file, all the modules and dependent resources are defined. This file helps to deploy all modules with dependent resources at one go, and it connects all of them together. So the operation for which the application is developed can be performed seamlessly. So this is, and there is one more file in cap application. There is one more file, package.json. So basically, package.json is a descriptor file. Okay, descriptor file. So all the dependencies and basic information, destinations are defined in this file. So these are very important file. Let us create one cap application using template, and then I will show you about all these files and scaffolding patterns that we follow. So let us create one cap application now. So here you can see, first of all, I will go to the file. First, we will use the template to create a cap application. Later, I will tell you how to create without template. So templates are recommended because they are generated and provided by SAP. So here you can select, there are multiple type of, if you want to create basic MT application, you can do this, and lot of generators are available here. You can develop UI5 application, adaptation project, and there are multiple Fiori generators are available. So here our agenda is to create a cap application. So I will select it, this cap project. This I have to select. So here you can see that create a new SAP Cloud Application Programming Model project. So click on this and go down, and here you see there is a button in the footer that is the name is written is start button. So you click on this button. Here you give a name. So I will give a name cap. So this is a name that I'm providing to my application, and you can select the runtime, right? Node.js and Java. So basically we are using Node.js environment, uh, runtime programming. So I'm selecting Node.js. These things, for now, there is no need to select. Later, I will add all these things. SAP HANA Cloud. We are going to create one application, and we are going to deploy it in HANA Cloud, and also how to use HANA Cloud Central Tool and HANA Cloud Database Explorer. Or all these things we are going to do, and how to deploy using CI/CD pipelines. So we are going to do all these things, implement XSUA. So we are going to do all these things manually and step by step. Later, we will use Joule AI to create a CAPM application and build code. So on time, I will keep explaining all these things one by one. So for now, just give a name and select the programming you are going to use. So that is Node.js. So click on finish. And you also see there is a start over button. So this start over button, basically if you want to restart this selection, you want to select another generator or template, so you can start over and come again. So this is one option that is available. So let us click on this finish button and move in. So here you see scaffolding pattern, right? This is a cap purchase. This is our application. So see, this is app. Basically, in app, we create a user interface, or you can say front end application. Basically, we create Fiori application. Fiori is a program. Basically, Fiori is front end of SAP, and we can create front end applications. Uh, so that is itself a module, and here we are going to create application using Fiori elements and annotations. So, and in DB we create the schema and entities. So all these things we will do here. In SR we will create service. So first of all, let us explore package.json file, right? So in this package.json file, you see the name of our application, the version, and you see the dependencies. Basically, this is the node. This is the node where this is the node, or you can say the package where this uh, CAPM, basically this CDS, SAP CDS, this is the package where all the classes, libraries, and functions of CAPM is defined. So this library, basically this template install everything, and see, these are by default installed. And you see that the start script, so basically it will run this command CDS serve. So if you run command npm run start, so this will run this command. And this is the dev dependency. Basically SQLite, we use SQLite to store data in a local host server and test our application. So we are going to use this, okay, use SQLite and create a schema, and then later we will deploy this application to the HANA cloud and implement security, access UA, authorization, and authentication. So anyway, for now, we can create an MTA file also. So, but one more thing I want to show here, this we have created by following template. So I will create one more folder. Click on this project, because we want to create a separate application. So click on this, and new file, and there's a new folder. So let's say cap test app. Here there's nothing, we are not following the template. So okay, click on this allow. So open integrated terminal. So this terminal is open now. So there is one command CDS init. So here you see that adding field set Node.js and successfully initialize the CAP project. So this command is used to initialize CAP project. So npm init. You can also follow the template. So to initialize a CAP project. Also you can done this by following template. So here you can see the package.json is created for this and all these things. SQLite and these dependencies are here. That's all I want to say. Now we can delete this. So from here, the everything is same. And yes, see the scaffolding pattern. The scaffolding pattern is JSON, right? So here you see that the package.json file is inside the root folder. This is the root folder, the name of our application. And MTA file will also be inside this root folder only. So let me open a terminal for this and we'll delete the previous one. Let me clear this. Mm, So it is clear now, and here you can run command cds add mta. So here you see that mta.yaml is created, and you see that this is the module. We have one module srv, and let us check if it requires everything. If it will require any resource, right now it is not, but we will create access UA resource, and it will require basically because access UA is for authorization and authentication purpose. But for now, let it be. So here I said that all the modules and other things will be there. So, so the second command we run is cds add mta. Also, so these, let us go back to the package.json and you see that this dependency and these dependencies. So this is my mistake. I can delete this because this dependency is there. Basically, dev dependencies uh, are required during the development in localhost, and this dependency is basically these will be required even after the development and deployment. You deploy this application to the cloud foundry and it will require these dependencies to run your application. Otherwise the cloud foundry will not that runtime environment will not recognize this. It will ask like this is not found. So now there is one more command npm install. So sorry, npm install. Yes. So here you say that these 110 packages are installed. So it will install all the dependencies and dev dependencies here. Later we'll add other dependencies and dev dependencies while our development. Whatever the requirement will come, we'll keep adding those dependencies. So I'm adding these steps. So npm install to install dependencies. Fine. Okay. So let me clear it now and we will create the schema. So I will explain you the scaffolding pattern. So the scaffolding pattern is of CAPM. So we have a root folder. So in so this is our root folder, and this folder has some other folders: app, srv, and db. And these are the folders, and we have some files also: mta.yml. These are important files. Package.json. So the two I'm mentioning, there could be others we'll explore later. mta.yml. So here we will create the schema. We'll create data structure, and this is, you can say, here we will create a OData service, or you can say that will act as a CAP based API. Fine. So now so here I want to let us discuss the POC that we are going to create here. So I'm adding one more slide. So we are going to create one, suppose POC we have, and that is manage purchase order. Okay. So manage purchase order, basically what it can do, it can display list of purchase orders, create, change, delete, and this is the, and create, update, delete, purchase, create new change order, and then these operation it can do. So basically we are going to do this, and also we'll implement a draft enabled. We can draft our purchase orders. We are going to do all these activities. So this is our POC. So to do this, basically a purchase order is a legal document between vendor and buyer, where goods quantities, you can say material quantities, price, taxes, units, etc. is mentioned let me adjust this. Okay, so in this application we will create some tables. Okay, purchase order, purchase order items, suppliers, purchase order type, purchase order status. So let us create this schema for these tables. So when we deploy this schema, so in HANA Cloud, all these tables will be created automatically. So let us create one by one. So in DB folder, as we have discussed the scaffolding pattern, that in this we will create the schema, and here we will create the service, and in the app we will create front end app user interface. So basically Fiori is Fiori application is created here. So we'll create a Fiori application using Fiori elements. Okay. So let us create the schema. So in this DB folder, right click and click a file schema.cds. You can give any name. Just make sure that you give CDS. This extension you have to give. Here, let us create a namespace, and I give this namespace is PO schema, or we can give one underscore. Okay, and then you can close this with this semicolon. So now I will create one entity for purchase order. Purchase orders. So here I will give a key field, purchase order number. So give this a colon, and you can give uh, data type here. So I will give a string data type, and size is 10. So it is also like this CDS 9 we are using, and it is suggesting the fields, like we in purchase order there is a supplier field. So let us follow this suggestion anyway. Order date, right? Total amount, okay. So let us all let us add all the fields that will be required in purchase order header. So I've added a key field, purchase order number, and the length of that, you can call it field or you can call it a property. So that the length of this property is string 10. So here we are getting, so let me delete this, and I'll add one by one. So let me add purchase order date, and why we are getting this error? No artifact has been found with purchase order number. So basically this is the mistake. We have to remove this colon from there, and now we will, this is our entity that we are creating here. So yeah, so now I will add supplier. So for supplier we can give length is also we can give 10, that's fine. And let us give the description of purchase order. Let us give amount, and yep, it can be decimal 15 and 2 decimals. So this here we are also getting suggestions also. Let us add currency here, company code. So company code this, and we can also give company code name. Mm, so these are the properties we are using. Company name. So this is suggesting the names. It basically, this is the foundation is AI. So these tools are advanced, and these are, they can understand our requirements. So they predict not only the libraries, functions, or variables. They can also predict, like, we may be needing these fields, these properties we be needing in this business process. So this is these are the advanced features. And so you can add other fields like purchase order, purchase organization, and we can give a string 4, and we can assign one property to store the name. So that's fine. And let us give the address. So basically it is the address of the buyer. And we can give status. Later we'll add more fields. Right now, let it, we are creating type and status. So these are fine. And now we will add some other fields. We'll create one more entity, purchase items, and see, it suggested all the fields. Okay, so automatically see the suggestion. So anyway, I will explain these fields. So this is purchase order item, and we see that the key field is purchase order number. So basically purchase order item is, suppose one purchase order have multiple items, right? So later we'll create an association between these header and item entity. So we create one item entity because one purchase order can have multiple items. You buy one many items at a time at same time in the same order number, and the same order number is generated for this. So that's why we are creating this table. And the relation between the common property between this is uh, purchase order. This is the purchase order number. So we will create association later, but now create entity supplier. So it is suggesting the supplier also. So I'm not using ID, I will use supplier and supplier name. Let's say number. Okay. So this, you see that this is the, this how advanced this business application studio is. So it can simplify your development. It can give you suggestions, and this can improve your development process. You can develop applications quickly. It can increase the speed of your development. So all right, let us create so I'm not creating much entities, and I'll stick to these uh, so we can explore all the simple and complex concepts So here you see status code and yeah, status description, and I will okay, I will keep it as description only, no problem. Okay, no need to do that because it is a separate entity. I don't want to do that. It is suggesting. So here, see, it is suggesting purchase order type as well. So type code. So status code. Okay, type code, no problem. Or we can give a status. So okay, all right. Let us give it the name is status description, and here type description, or let it be. No problem. Let it be. So we'll say because here we have status and type, so I'm keeping the same in this one. No need to put code, and just type is enough. So this is fine. And okay, the length is 20 and description is 250. Even this is let us give some more regional space. No need to give, even if let 50 character is fine for me. So you can decide, so you don't have to allocate much uh, space. So you have to decide these things, and you can give 100 to this email, or uh, so country no need to give, maybe 20-30 maximum. 20-30 characters are enough. So that's fine. Address you can give, and supplier name also I'm giving 100 digits. So that's all right. So we have created these entities. Now I will create a service. So so in this service, okay, before that we will perform some commands, and then we can develop our service. So right click and open this application in integrated terminal. So clear it. So open db, so you can use change directory as db. So change your directory, navigate to the db folder inside cap purchase order, and here run command cds compile and schema.cds. This is the okay, no, my bad. So let me close this for now, and schema.cds. So this schema is compiled. Now run another command. So you can give to and SQL. We will use SQL Server for testing our application in local host. So here you see that, okay, I'm increasing the size of terminal, and you can see that the tables are created. Tables are created with this name, this the schema name, and then the entity name, and then purchase order items and supply. So this is the name, and here you see. So you see all these the tables you have created. You can run queries and uh, try to fetch data and insert data in SQLite. So you can do all these operations. Later we may do it, but for now let us create. So this uh, we have compiled our schema, and now let me paste these commands for you. So yeah, new slide is created. So we have created a schema. We have created schema.cds inside db folder, and entities we have created commands, I will say this one, and cd directory, like change directory db, and then run this command. Okay. Mm, like this. And here we have created, let me I'm not going to paste these entities. I'll just write the names so you can refer later. Purchase order, purchase order items, and supplier, purchase order status, and purchase order types. Fine. So we have created these entities in this schema.cds are created. Okay. So change directory, and we will run compile our. So I'm removing this. So you do the change directory and then run these commands. So to compile your schema and compile your schema to SQL. Now there is one more activity that you have to do now, and make a change. You have to insert this. So we have to insert this CDS thing, CDS, and we have to give some details such as here you see. So we inside we have to CDS, and we have to add requires. Basically it will require the kind of data. So right now we are not using HANA Cloud, later we'll do. And for local testing you have to give SQL. So we'll create the data, but this is the we have to update. And even we if we are adding any uh, destination or service name, service destination name, that is configured. So we add all these things in package.json start scripts. And suppose we are later we are going to check app routers. So all those things, like to start your Fiori application, we have to create app routers. So all those things we are going to insert in package.json. So I'll make notes for you. Update package.json file. Let me make some space. So this will be enough, probably enough space to paste it. Okay, let me do something. So I'll let me make some room for more text. So this is done, right? Yeah. So you have to run these commands, and the package.json we have updated. So these you have to add for SQLite localhost testing. Okay. Now let us create a service and then add data and test our application. So now we'll create a service. So new file I'm creating and I'm giving a name purchase order srv dot cds. So to create this service, we are going to use PO schema. We are going to use this schema and this namespace we have assigned for this. So let us use this. So how to use this? You have to use statement using and these braces, and I put it here. I can give as and will refer to the name POs, and you have to use from, and you see that this is the folder. Basically, one here it's a right now we are this file, right? This file is inside srv. So these two dots increase indicates that the parent of this file, the parent of this file is srv, and the the next parent, the next dot, that this is the parent of srv. So the parent and the parent of parent, so that is root folder. So now you see the path inside root folder, it will go to db and then schema. So you don't have to give dot cds, so this is fine. Now we'll create service. So you run this service. So you can see that it is suggesting, but anyway I will create. So give a name purchase order srv. So I don't want to uh, use the suggestions. So here you use the entity, and I want, like, suppose purchase orders. So let okay, we have used this suggestion, but I will explain you. So entity, basically, let me delete all these and we'll reinsert. So here you see that we are creating one entity. So basically it will be the entity set. So okay, let so entity set, basically these are the collection, they store the collection of records. And entity type, basically they define the structure of the uh, entity type. So like purchase order, this entity is going to hold number of records, right? So when this service will be generated, one entity type will be created, and for that entity type, one entity set is created. So that entity set is going to hold the data. So I will show you all those things. So as projection from, because we are projecting, because this POs is just, we are referring, it is a reference name we have created. So this is referring this schema. So PO's purchase order. So this will refer to this entity. So this is the type, right? This contains all the field, and so a entity type is created for based on this entity of this schema, and this entity will create one entity set. So likewise we will create all others. So I'm, yeah, let us do one by one. So it is suggesting this business application is studio is modern and highly advanced tool. So this is created. Okay. So now, okay, we have already done this, and now I'll jump to my root folder. So cd dot dot. So again, I'm back to my root folder, and then I will create data. So you can create a folder here inside db data folder, and here we will use CSV files to uh, create data. So we can run our application in localhost, and when we deploy this application, this data will also be deployed. So if you don't want to deploy, you have to move that data in test folder, that I will let you know. But for now we can deploy this data. So this data will act as a legacy data. So with this when we deploy this application later on HANA Cloud Container, so it will be stored. Even in HANA Cloud Container, we have tools, a lot of AI powered tools to change the data, view the data. So we can do all those operations. I will show you everything. So the service is created. Now we have to create the mock data. Anyway, so one more thing before that, let us mm, okay, let us create the data first. So now I will create new file. So the name of my schema is po underscore schema, and then hyphen, and name of my entity is purchase orders, right? Purchase orders dot csv. Later we'll put this data, but now, or we can upload this if these files exist in our system. Maybe exist, I'll use that data anyway. So but we can create these files. We can also upload these files if you have these files in your uh, uh, PC, so you can do that. But I'm creating this for you. New file. So if you understand the data, so items, right? Item directories, we'll put item data here, and then I'm creating one more file, and here we will put supplier.cds. Suppliers it is, not supplier. So anyway, no problem, we'll correct it later. And let us correct this. This is some wrong file created, so we can delete it, and now I will rename this file. We'll put one s here, and okay, rename it, create a new file. Purchase, no, it is still wrong. Okay, but I'll fix it. Purchase order status. Well, here we will keep status data. And make type, right? Type. So we have created these files. We have to add data here. So, or we can, if you have data, we can directly upload these from our system. So for now, I may not have it, so I'm creating these. Purchase supplier, no, it is not purchase supplier. So just correct this. Purchase order type, purchase order status, suppliers, purchase order items. There is some correction required in the name. This A will go. Purchase orders. Yeah, it's correct now. You have to correct all these files. Purchase. Okay. This one is fixed. This is fixed. Purchase order status is fixed. Purchase order type is fixed. Purchase orders and purchase order items. Items is not fixed. It requires some correction. So let me correct the name. And then we are going to add data here. So yeah, one by one they are you can see the files are in sequence, so we can keep our service also in this sequence. So we have purchase order, then items, status, and this. So right now we don't have any data, we just have files. So let me add this data in these files. So here you can see that we have created CSV files to test our application with mock data. So let us check this data. I have added this data. So fine, we'll compare this data. So let me open schema.cds side by side and we will compare the fields. So here you see that we have purchase order. Here we have purchase order number, order date, description. So these properties, all these properties, so in the same sequence, we create a CSV file. So the nomenclature of this CSV file is, so you have to give this namespace and then hyphen and the name of your entity and then .csv, and you have to follow this sequence. So you have to follow this sequence and all the properties are comma separated. Suppose if you don't want, suppose you don't want to give this value. This value is maybe the company code, right? This is the currency and INR. So this is the company. If you don't want to, so you have to give nothing and give a comma. If you will remove this, this data will be wrong. So like this, I have created data for you. So all these properties, like this purchase order number, so this is the value. So this is comma separated data. So if you want to keep something blank, you just suppose if there is one more column, let's say for demo last call, I say. So if you don't want to give value, so you have to give space, comma like this. And if there is last call 2, so you give like this. So there's no value for last call and for last call 2 also. So like this you have to, otherwise it can result some give some error that you have to check in the console. So you can check the console also, there is no issue. So here you will, when we'll run all the result, you will see in this console. So as likewise I have created this data. If this name is correct and the data sequence is correct, you will not get any error. So here see, I have created this purchase order. This is the purchase order number, date, and a description. And see, let's see if we have this. So this is there, and item 10. This is the item number. You can follow 10, 20, or 123 like that. This is like item number or serial number that you give. So order status, you see the status: draft, pending, approved, rejected. So this is the status of purchase order we will get from here. Let me check what is the status that is showing here. So see, approved, approved, rejected. So let us check if this status is there in our status file. So yeah, approved is there. So all the data should be correct and mapped. So if you understand the data and the flow of the data, then the whole process you will able to implement. So how this data is going to uh, work for your purchase order, is the flow of the data, and basically we are going to create a reporting tool and API to get this data only. We have to manage this data, post in some uh, proper format. There is a, like, suppose if there is no some other status you give here, so you don't want to, you have four statuses of your purchase order and you want to restrict them. So it will not allow to select. When you create application, you don't want to allow some random status or random supplier, because the supplier who exist in your system, those should be allowed, right? So we have to take these things in mind while development. So understand the data, its structure, and manage the data accordingly. Anyway, so I have to run one command to deploy this data to SQLite. So CDS deploy -to SQLite, and we have this namespace. So mm, let me correct this, and so you can use it. So this command is, so maybe we have not used a valid command. Yes. Okay. See, there is a spelling mistake here. Unknown command. So let us check the command entered here. So yeah. So there is one. So let us try to run this and check. So see, we got some error. Our data is deployed, trying to deploy, but we are getting some error, right? So let me check what error we are getting. These errors are very important and you have to fix these errors. So it is saying that purchase order has no column purchase organization name. Okay, so maybe this is not able to find. Okay, let me check out my SQLite structure that we have deployed. So purchase order, purchase organization, and purchase organization name, it is there in our uh, SQLite, and it is compiled properly. So purchase orders schema purchase has no column purchase organization name. So maybe the issue is in our CSV file. So what it is saying, purchase orders. So, okay, let me check. But see, our it is triggering, the data is triggered, right, to deploy to SQLite. So that's fine. So maybe our header, let me try to copy this purchase organization, and what we'll do for this, if everything is correct, right, there is no issue. So I'm closing all these. files, and I will open them. So here I will see that purchase organization is there, right? But it is saying that this is the error here. So sometimes when we copy paste this data, maybe something happens. So let me try this. It may work. And so that's why we should. So this data is dummy data, and these things are created by expert when and the functional and business consultants. Anyway, we can do the development with this. Let me try to deploy this application one more time with the same command. Let us check. So now you see that it is deployed, right? So maybe the issue with the formatting, or maybe I have copy pasted this data from Excel file. So there could be a version difference or something like that. So if everything is fine, you try to replace the headers, and also you can check the data. Something is there, or some syntax error or something. So try to figure out. Now we'll do. Let me write this command to uh, make note for you. Okay, so fine. So we can do this here also. Okay, or let me create one more slide. So yes, let me expand this, and okay, it's not expanding anyway. We'll give the text size is 10, and this is the command you have to run to deploy your data, and this is the schema name that we should give, and deploy to SQLite. Now run command CDS build. Okay, so this will build your application, and this command is case sensitive. So when we build this, let us try. So right now I want to show that there is in this gen folder, right? There is nothing in this gen folder. So when I will run this build, so see, gen srv package log.json package.json, and this thing is created. So basically when we deploy our application, so this gen folder is deployed, this gen will deploy. Okay, and whenever you make change in your schema, at your schema level, if you make any change, so you have to recompile your application, recompile, sorry, your entities. So you have to run these this step you have to follow. If you make any change in the schema, if any change in the data, you are deploying then to SQL. So you have to run this statement. Okay, and again you have to run CDS build. So if you are making any changes at schema level, any change in entity, so you should not do uh, without proper approval, or proper calculation what could be the loss you can, that can be a data loss, or so don't, these change is not recommended without proper analysis and impact analysis. So all right, and then we will run command cds watch. So let's see if everything is correct. So localhost is created for our CAPM application. I will open and I will see this. So fine, here you can see service endpoint is created, and this is the URL of our service. So I will not. So let us check this. So this is the service, and here you can see these are the entities created. So in upcoming class I will tell you how to do operation filter and format these entity data, and let us quickly check what data we are getting. So see, our data is correct, right? So this data is correct and all we are getting. So this data can be deployed to the HANA cloud as well as your legacy data. And anyway, there is, yeah, this is, and go back. So all the data is properly getting populated. So you, this is the Fiori preview. To preview, let us click this. So uh, this is a Fiori preview it is offering, but later we have to develop application. So how to do this preview? You can go and select columns and click on this, so it will give you a report type of thing. And so fine, this is the automation, right? This is the result of automation. So now the thing that we, and see here that by default the OData service created here is v4. So here I will write, so run CDS watch. Also you can run CDS serve. So CDS watch, there is a difference between CDS watch and CDS serve. I will tell you. So in localhost, this is advisable, but in package.json, we keep the start script as CDS serve, right? These are the start script. But suppose if you are making any change in the localhost, you are changing your data. So if you are frequently making changes in your dev environment, okay, so you have to kill the terminal again and again. CDS serve again and again after every change. So CDS serve watch can save you from this. So this is the advantage of CDS. Sorry, this. Let me correct this. Okay, so yeah, I so you have to kill the terminal and repeat this activity. But if you are running CDS watch, so this is, so see, you can see here we have CDS watch, right? So, and see, whenever we are performing any activity, right, in console you can see that the count is there, select is there, skip 0, we are not skipping any data and we are displaying top 30. So even you see that this is the post operation batch calls. Basically batch calls are the post operations, and we in here get purchase order is done. So let me run one more times something and you will see I am checking purchase order types. So there is no value in purchase order types. We'll see this. Okay, what else? It's not displaying the value. It is correct. Purchase orders is correct. Items is also not displaying any value. Supplier is displaying. So we'll see this data. Okay. Mm, fine, purchase order. So see, all these activities are marked, right? Here you can see the console. So this console will see all here you see that OData and this. One more thing I want to make a note, and see, suppose here in this data I will click save, control plus S, and you will see that localhost is restart. But if you are running CDS serve, this will not do. Anyway, when you deploy your application, here the start script should be CDS. So because we are not making any change after the deployment, so there is no need to recreate this uh, host name and uh, the domain name and so port. So no need to, this is the port and this is the domain name, so we don't have to create this. But in local host we are changing our code, we are changing our test data frequently, so we have to this, you it can save some time. Anyway, now let us check why we are not able to get type. Okay, so let me check the entity first. Maybe we are doing some mistake. Here you see the type is there. So I think we have used types. I will save, and you see that localhost is refreshed again. So let me go to types, and you see that we are getting data now. And again we will open items. So let me check items, maybe purchase purchase order items. I'll copy paste and rename this. Okay, PO underscore schema name is correct, and all right. So first let us correct it and then we'll check. So again this is refreshed, and see now we are getting this data. Okay, so maybe some name was incorrect, so we were not getting this data. So and also like how to get this error and how to fix this error. So it is good like we are able to demonstrate errors, because this tricky type of errors make complexity, because if everything is correct, your data is correct, the structure is correct, so how will you identify the error? So like this anything can be there. So a few notes that I will give, that the OData service will be created here, will be created by CAP SRV, and the version is by default V4. You said that the V4 is the version latest. V4 OData service will be created. So but we can convert this V2, sorry, V4 into V2 by using proxy. So we'll do this later. Uh, Later we'll do this. It's not required now, and I will show you what is OData. So let us see this. Run this OData org. Here you open this OData org. Okay. So basically, OData is Open Data Protocol. So it is ISO and IC approved. These are the standards that it got approved from, and basically it defines set of practices and building restful APIs. So the OData protocol is used for building restful API, and it can be easily integrate with front end. Okay, so all HTTP methods. So this is very lightweight and easy to use RESTful API. So here you can see, and this is the metadata, right? OData metadata. So I have demonstrated, right, the metadata. Okay, I'll first let us check this, and then I will show you the metadata and explain it. So here you see the OData v2 and OData v4. So these are the dummy OData services you can check here. So let us see that this let us display this category. Suppose this data we should display. So here you see by default this data is JSON, right? So you can change the format. So no, sorry, this by default this data is not JSON, this is XML. So let us change this format into JSON, and you can do this pretty printer. Here you see that this metadata is coming, products, and these properties are coming. So let me choose some other entity. Okay, let me choose this orders, because we have developed purchase orders, right? So now you can see this is XML. Okay, so again we do this, change the format for our use, but by default it display data in JSON format. So these are the order IDs, and here you see that there is a D folder and results, but in V4 it is not like that. In V4 you will get data by default in JSON, and there's no result folder, and that is faster than lot of other functions and facilities are available in V4 that those are not available in V2. So we'll later uh, we will later explore all these differences and advantages and scope of V2 and V4. So here I have told you. Now let me explore V4. So that this dummy T pin, and see this is the metadata, and here you see okay, these are the entities, and you see that by default we are getting JSON. Okay, JSON data we are getting, and these are quick and even faster, and we don't have result here, we have the values, right? So, and we'll explore all other advantages of V4 over V2. Now I will show you the metadata. Okay, it's a metadata driven, right? So what is metadata? So metadata basically defines anything that defines the structure of anything that defines the structure of a resource. Here our resource is OData service, right? So the service, or you can say our RESTful API. So this is so let me show you the metadata, okay, for our cap. So go to this metadata. Okay, I'll paste this URL also here. So this is a hyperlink, and we'll bold this. And now, so here you see that this is the, like here this EDMX basically EDMX, in we get the metadata of this, and here you see the standard name, and below you see the containers. Basically containers store the entity sets. So what are entity sets? Entity set are the, like, this is our entity set. So when we call this, so it will get the data. So entity set basically hold the collection of data. Entity set data collection, and we have, right, I have already explained this, but here see that the entity type you can see, right? Entity type, so purchase order, SRV, and purchase order. So this is the entity type. So entity type defines the structure of entity set, right? Here you check this purchase orders, right? The field and the length, and here we are using a string date. So in OData, the standard of date data type is EDM. So this is entity data model. So all the types will be created with this data model, EDM, entity data model we call it. And so all this container, entity type, entity set, all these things are metadata entity. So all right, let me close this, and so entity type, even the property. So this property name type, all these things, max length, so all these things are metadata. You see all these things. So all these things are defining the structure, right? And here, like the one, that entity container, basically it holds the uh, it's a array, you can say, that holds the list of our entity set. So so even the associations that we have not discussed in the upcoming classes, we are going to discuss about the association, like we have entity set and entity type, so we have association and association type. So we have this, all these things we have. Let me bold this. Okay, let us change the color. This color is not that much good. Okay, now you see, so all these things, what is entity set? And suppose you want, so if you want to get data of dependent entity set based on parent entity set, so you have to create associations for that. So these are created to get data like 1 to n. So sir, header to item, right? Header to item. So you will enter one common property should be there based on common properties. So header item relationship 1 to many. Okay, so this is the mapping. Okay, so here, like in our case, we have a common property, that purchase order, right? We have purchase order number. So in this case, we have purchase order number as a common property. So we can get data, all the items of our purchase order number. So we can get, like, what are the purchase order numbers exist in header table, and for those purchase order numbers we can fetch multiple items, so one to many mapping. So this is association. Okay, so yes, so in upcoming sessions we will create association and association type, and we will explore other concepts also. So this is it for today. Thank you.